want to develop for chip. Then we'll be going through all the features, and we'll be reflecting a little bit on the project, the challenges we overcame throughout our experience, and then future research, things we would like to develop on chip later on. Okay, so our application here, what we've been working on is to use chip to deliver medication and meals to patients at an aged care facility. So an application that was more focused on Scotland. Here, so we came up with these different features that would have to be integrated in order to have this particular application working. These features included voice recognition, face recognition, navigation, object manipulation, and speech synthesis. Now those might seem a little bit complicated, but hopefully by the end of this presentation you will be expert in robotics and there will be no problem understanding this. Alright, so now I'll move on to Kevin, to Luke, who's going to talk about face recognition. Thank you.
Yeah, so hi, I'm Luke. I was working on face recognition. So how the face recognition works is it will first look to try and detect a face. Once the face is detected, it will just then try and recognize the face and see if it knows the person and if it's already met them before. If it doesn't recognize them, then you can get it to train and try and figure out who this person is, tie it to a name so that you can use that in the future. And if it does, then cool. Face recognized, you can pass it on to the next program. So a few applications for this in aged care specifically. So it can be used to deliver medication to the right person. So obviously with medication, you want to make sure that it goes to the right person. And using face recognition, you can help verify this. Another application would be to check to see if the person is staff or patient or visitor. So based on they're already, if they're in the database already as staff or patient, chip could do certain commands that based on the category that it detects. And finally, also it could do personalized behavior. So with, depending on the person, if they've met them before, it can bring up a personalized greeting, and this just makes it more human and more friendly to interact with. So yeah, I'll now hand you over to Kevin, to do voice recognition.
So my part in this project was to implement voice recognition on chip over here. I maybe biasly believe this is the most important feature to be implemented. It's the main way that we're hoping to be able to communicate with chip, and it's a nice natural way of communication, much better than having to use a controller or something, and yeah, it just provides a better experience. So what we have today, chip is currently, hopefully, listening to everything that we say, but he's not doing anything yet, so to get this to happen, we implemented a safety feature, so you have to greet him every time you want to give him a command, just so that he doesn't do random things that people are not expecting. Unfortunately today, nobody here has been able to get the internal microphones on chip working, so that's why we're using the external Bluetooth. We're not cheating or anything. So I'll pass you on to Tom to talk about his part.
Yeah, my part was mapping. Chip uses a predefined map which is loaded onto him and slammed at the same time for location. It allows him to pinpoint where his location is within a room. Using this virtual map, we can also add pinpoint locations. So for example, with our application of the retirement home, we could say if we want Chip to take medicine to a certain room, that will, the person can tell him the room number, and that room number will correspond to a point location on the map, and then Chip can navigate there. We can also add boundary constraints, which will stop Chip for leaving the building, going outside, or maybe entering certain rooms that we don't want him to go into. I'll pass you over to Avery, which was doing navigation.
Okay, so our main project scope is to make chip to deliver the medication to a patient. So obviously it has to travel from point A to point B. So with chip, they already have a built-in system of SLAM to do the hard coding stuff, which allows, by taking in inputs from the ultrasound sensors and the lasers, it can identify objects and carry out the object avoidance algorithm, and also do the path planning automatically. So you can travel autonomously once you give it a navigation goal, and it will travel from point A from point B very efficiently and very safely. Yep, we'll pass it on to Daniel.
Thank you. Okay, so a big part of our project, particularly with our use case, is object manipulation. So this is actually getting the robot to interact with physical objects in the real world. So this is quite a complex task, and essentially what it is what we want to do is we want to identify a specific body part in the robot to go to a certain point in space, and then at that point use the hands or whatnot to manipulate an object. So actually mimicking human movement in a way that allows you to go from any other position to a position where you're picking up an object is quite a complex task in itself. So it's in just the robot's arm, it's got 7 axes, 7 degrees of freedom. So that's one axis moving there, another axis here, and then again another 7 degrees of freedom just in the hand itself. So all up in just a simple movement, going to say pick up an object, that's 14 degrees of freedom, so 14 joints, 14 axes in order to pick something up. Another part of the project which we're kind of hoping to work on in future is object recognition. So that's physically using the cameras to go, oh, okay, there's an object there. Is this an object I can pick up? Is this an object at all? Or is this a table or like a couch or something? So that's probably something that will require a bit more work and is probably another PhD in itself. So yeah, I guess we'll be working on that a bit later. I'll now hand you over to Connor, who will talk about text-to-speech.
Thanks. Hi, how you doing? I'm Connor, obviously. So my part was speech synthesis. So speech synthesis is, so it's taking, sorry, my bad. So it takes a message from the other parts, it takes no user input, it's all predetermined by the other parts of the program, such as voice recognition for a reply to a command, or navigation for a completion message. So like I said, it takes no user input, it's all predetermined by the other parts. And yeah, that's pretty much it on speech synthesis. I'll pass you back to Thibault, who can conclude our presentation. Thank you.
Alright, so now we'll move on to the demonstration. That was a lot of talking, but hopefully we'll see it actually move. At some point, I'll run you through what we are expecting to see here. As you saw throughout all the other demonstrations, chip has kind of a mood. You know, if it's not happy, it's not going to do anything. If it is, well, hopefully it will move. So, what we're expecting to see here, first upon a certain word, of course you have to greet chip, but then upon a certain word, it will take this word or this sentence as a command and execute that command. So it will first pick up this bottle and deliver it to Mr. Kevin. Deliver it to Mr. Kevin. When chip recognizes Kevin, sees that Kevin is standing there, it will extend the bottle and actually give it to Kevin, who will be receiving it. Okay, so are we ready to run?
We're just running with the theme and everything.
Okay, so yeah, the big issue throughout this